Okay, so here's corollary 1. Now, corollary 1 says the rank of a linear map is less than or equal to the dimension of the domain. Now, the equality holds if and only if the nullity of the map is 0. We saw that in the previous example, right? Now, one thing to mention, actually a couple things to mention, is we know that an isomorphism exists between two spaces if and only if the dimension of the range equals the dimension of the domain. Now, we've now seen that a homomorphism, for a homomorphism to exist, a necessary condition is that the dimension of the range must be less than or equal to the dimension of the domain. Okay, now, the range space of a linear map can be a dimension strictly less than the dimension of the domain, and so linearly independent sets in the domain may map to linearly dependent sets in the range. And we've seen examples of these transformations in previous examples. The derivative transformation, for example, that is under a homomorphism. Independence may be lost. Okay, so under a homomorphism, independence may be lost. Okay. In contrast, dependence stays. In fact, that's going to be the next lemma.